valve, safety shut-off valve, and pressure regulating valve. So they are not very interchangeable, but if you go to one industrial park, they have their own list. So again, the 5 sequence of operation, I'll keep repeating those because they are very essential. Sometimes there are 5, and sometimes there are 6. So it's pre-purge, pilot, third one sometimes is proving there is a pilot, main burner, flame established, then running period, which is putting the system on auto run, and post-purge. So those 5 are very essential to a lot of controllers. And some controls have lights or LEDs to tell you which stage is the burner on. So this is an example. I took this from the Honeywell manual, that's why it looks kind of old, but it gives you an idea of how many valves are required for this burner. So this is from in Massachusetts. It's part of the code between 400,000 and 100,000 BTUs. This is the amount of, this is the gas strain you need. And this is here for the pilot. So a line comes from the pilot to light the pilot. And the pilot has to be also the same fuel. Why is that? If you have the same fuel light up, it will have the right temperature to light the main fuel. So you don't want to use a different kind of fuel for the pilot. However, the pilot, if you see the Cleaverbrook here, it has gas line, it has oil line. It can alternate between gas and oil, and the pilot flame has its own line. It's also gas. So when you use gas, you can use the pilot flame, and when you use oil, you need to have electrodes. Why do we alternate between gas and oil in the big industrial boilers?
Oil has more BTUs.
Okay, what else?
Cost.
Cost, we're going to go with what's cheaper. So we're going to have 2 sources of fuel. If it happens that gas is cheaper, we'll go with gas. If it happens that the oil is cheaper, we'll go with oil. And what else? Availability. Sometimes there's not a lot of oil available. There are shortages, so we use whatever we have, whether it's gas or oil. So between 400,000 and 100,000 BTU, this is the valve strength required. There's a manual shutoff. There's always going to be a manual shutoff valve. Another manual shutoff valve. You see the lever here. You can turn it. Pressure regulator valve. What kind of valve is that? So we have solenoid, motorized, and diaphragm. What do you think this one is?
Diaphragm.
Is diaphragm. It looks like some kind of valve you'll see on your grill. Safety shut-off valve. These will shut off right away and very quick. And mostly they are solenoid because they're very quick. Another manual. If you see, there's a lot of redundancy. 2 manual valves between the regulator and just to the main burner. And every light has its own shut-off valve. In case the other ones that didn't respond, you can go manually and shut it off. So between $1 million and $2.5 million, we're gonna double up on valves. Again, manual, manual, manual. We have 3 manuals, 2 emergency shut-off valves, 1 diaphragm, and gauges. You're gonna have the gauges between before and after, just to make sure that we have no obstruction in those valves. So gauges are very common between before and after any valve to make sure it's open or closed. It's a very easy way to know if the valve is operating or not. And this is, again, so what do we rate? This is one of the questions of the homework. What are the gas and gas trains depends on? From what we're seeing so far? BTUs. How much BTU are we burning? This is mainly how do we rate those gas and gas trains. And gas trains are used for only gas and not for oil. So do not mix gas trains with oil. Oil is different. So between 2.5 million and 5 million, it gets a little bit more involved. 1, 2, 3. We still have 3 shut-off valve, 1 pressure regulator, 2 pressure regulators, and we have, in addition to what we had before, we didn't have that before, which is here, a firing rate control. It's called MDM. It has a damper that will regulate the flow, so you can have a flexible firing rate between 2.5 to 5 million, depending on how much gas you pump into the chamber. The pilot flame does not change between all of them. So the pilot is the same, pilot is still the same, did not add that much to it. Still the same thing, same line, does not change, because the pilot is always going to be the same. So symbols and notations, they vary from one industry to another, so do not think they're all the same. So always check with the measurement. Some of the terminology that you will use, I will want you to remember those things. A controller, start and stop the burner to maintain a set point in response to the control variables. So what are the variables we have? Air and fuel. And we want to set the pressure. So the pressure is the output that we want to have from the steam boiler. Primary or programmable controller, it supervises the burner operation. This is the same thing that you have in your car when you have it in cruise control. We have sensors that will sense the speed and will control the fuel, and the fuel will control the air. And in some advanced cruise control, when you go downhill, you can even activate your brakes. What happens if you put your foot in the brake while you're in cruise control?
Turns it off.
Completely disengaged. So the controller here maintains the operation based on the input. Our input here is the pressure. Limits, it guards the system from against dangerous pressures and temperature conditions. Similar to the residential heating. So you have high limit and low limit. So whenever you have a limit, it's something for safety. So we do not exceed the operating conditions. Pre-purge. So it's a blower motor that activate and blow air inside the chamber before we start the pilot and before we start even the main flame, because we want to get rid of all the residual gases inside the burner and start with fresh air. Ignition trial is the period of time when the pilot and the main burner must be ignited. So ignition trial for the pilot, ignition trial for the main flame. And what is the limit in seconds? How many seconds?
3, right?
Less than 3. Between 1 and 3, sometimes even less than 3. So we do not allow a lot of time for ignition trial in industrial boilers. Intermittent pilot. I mean, the pilot is on for the entire cycle. I know this term has been very confusing because intermittent can mean that it's not constant, but in this time it is constant, and the pilot is on for the entire cycle. And this is similar to what we have for residential. Post-purge, the blower motor runs after the cycle ends. And this is very common for gas. If you have a gas burner in your house and you turn it off, you will hear the blower motor still running to continue post-purge whatever residual gas you have inside the chamber. And did you ever notice that when you turn on your stove, sometimes you still smell the gas at the beginning, because when you first start pumping gas into the burner, it will seep until it gets the right concentration to ignite. So these little particles or molecule of gas get into the air and you get to smell them. So there's always a need for post-purge and pre-purge so you do not leak some gas in and out. Firing rate control. This regulates the burner firing rate. And again, how do we control the firing rate? What do we control? Carlos? If you want to control the firing rate, what do you control? Fuel. So you control the fuel either by opening up the damper for the gas, by pumping more oil. For oil burners, they have more than one nozzle. You can have a nozzle that will change rate. Sometimes you have 3 nozzles, 4 nozzles, 5 nozzles, or sometimes you have one nozzle that will change rate based on the pressure given by the pump. So we regulate the firing rate for the burner with the controller. So flame safeguard is primary control system perform the following. When they say flame safeguard, this is a copyrighted term by Honeywell, and it does a few things. The sequence of operation, that's what we need the safeguard or the control to do, is control the sequence of operation. We don't want to turn the valve before we turn on the ignition, and we want to have the right timing based on the gas or the fuel. Sense the presence of flame, so it does that. It controls the sequence of operation. It senses the presence of flame for both the pilot and the main flame. Check its own components, so you can go and send signals to each component to make sure it is on location or not. So for relief valve, we're gonna use a lot of motion sensors or proximity sensors to know if the door is closed or the valve is open or closed. And some of them have LED lights to tell you this thing is on or off. Actually, I have a proximity sensor that was built by a student last year, and he created the program. So this is a proximity sensor. They use those to make sure the door is shut or
A student built that?
Huh?
A student built that?
Yeah.
Nice.
So if you get a metallic object, it lights up.
A little bit of an engineer.
Yeah, he actually worked for Hood Dairy Farms. So,
That's pretty cool.
so those are very important to know if the valve is open or closed, if the door is completely shut or closed. And you will see a lot of those as you go around, and they're not really expensive to build. So, the sensitivity and the proximity is dependent on the sensor in here. A lot of these things you can build yourself, or you can, the sensors itself is not that expensive, it's how you wire it around. So that's a proximity sensor. It tells you that things are, without like having to go and check manually, things are on or off. There are two types of flame. That is very important. External and inherent flame. And this is going to be one of the questions in the quiz. What is the difference between inherent flame and external flame? So let me explain this. So external flame is when we have to introduce new heat, a technician or a pilot. Inherent flame is when the chamber is too hot that you do not need to ignite the oil. As soon as you pump oil or gas into it, it will flash right away. So I'll write it down. Inherent. So if we think of industrial boilers, they get really, really hot. If you're using gas, probably as soon as you pump gas into it, the existing heat will burn that gas right away without any source of ignition. Do you remember when we turned one of the steam boilers here, it was too hot and we threw a piece of cardboard in there and completely incinerated? That was the heat.
With no flame?
With no, huh?
With no flame?
No, there was flame, but it didn't catch on fire, it just like disintegrated. So the same thing will happen when the chamber is very hot, and that's why, yeah, that's why,
In the chamber?
yeah, it just ionized. So that's why you need to always do post-purge and cool the chamber before you introduce the flame and recycle. Otherwise, you will you have an issue with this with the sequence of operation. So that's the two different type of flame. Please remember that. Difference between primary control and programmable control. So programmable control, you can always change the sequence of operation. You can change the timing, and you can have other functions, like for example, sounding an alarm, or sending signals, or message codes to the control room. Primary control is set, and you cannot change anything. Programmable control, you can change it, and you can go into the logic of it and change the sequence of operation, whatever you need. And also it will store some information of what error you got and when did the burner lose flame, for how long. So the more information you know, the more you'll be able to diagnose those issues. unsafe failure and flame detection. Looks like the flame is present when it's not. So that's another issue with the sensors. Probably put the sensor in the wrong place. It's not detecting heat. Something wrong with it. That's something that's called unsafe failure, where the monitor says that there is flame, but there is no flame. How could that happen in your residential burner? What would cause that to happen? You can misplace your cat cell. Could be seeing the wrong view. The chamber could be open somehow. There could be existing flame inside the chamber, or the cat seal is disconnected, or it's there but one of them is disconnected. One of the prongs is disconnected, and it looks like there is flame, but there is no flame. This index here also is still there. If not, it's in Blackboard. So that's something you're gonna use for the homework to pull out those names. If you go here under references, it should be here. So that will give you an idea of how many of those acronyms we have, and it's really hard to remember all of them, and they are not universal. So do not beat yourself up if you don't remember all of these things. So I just want you to look at a few of these to just give you an idea. But this is special to Cleaverbrook Industry. So I don't want you to remember any of these, but at least you can save them in case you plan to go into industrial boilers. But some of these have become really common, like PLC. Everybody know what a PLC is. PRV, you know what a PRV is, pressure relief valve. But some of them are very, very specific to industry and whatever plant configuration you might have. All right, so I'll stop the lecture here and we'll do the residential questions.